Finland, we have a lot of clean water, I think about 300,000 lakes, and also a lot of fresh air, so we are lucky in that sense, but of course there are still problems, and especially with indoor air. So I present you genius nanotechnology developed in Finland. This technology was developed in 1990s originally, and together with universities and research institutes. Genano started operation in 1999, so we have been around for 25 years and now work internationally, especially in healthcare, also in industrial VOC abatement, and then in our home markets in indoor air quality. So this is the area where we work in. Just 2 slides about the basics of air quality. So when you talk about particles, there are large particles, fine particles, and ultrafine particles. The large particles settle to ground in minutes, some large and fine particles in hours, and for ultrafine particles, they can stay in the air permanently. And if you talk about human body, how the particle penetrate the human body, already the PM 2.5, which is used a lot when talking about particles, they can penetrate into alveoli in the lungs. But then there are the ultrafine particles that we have had problems for a long time, and they can be absorbed directly into the bloodstream. And according to WHO, they are the most dangerous ones, and they are especially important to treat. Our standard in the market has been a product which is actually developed in the 1950s, which is a HEPA filter. It can catch the size of 0.3 particles, so fine particles. The level for ultrafine particles is 0.1 micron. ULPA goes down to that. With Genano, we can go down to nano size, so 0.003 micrometers. There are the viruses which are that size, some ultrafine particles, including metabolites, and DNA fragments. Our technology, well, we have been around for 20 years, more than that. It has been widely tested in Europe by LNE France, HN Netherlands, SGS, some Finnish governmental institutes. And it's tested against particle filtration, virus and bacteria elimination, and gaseous compounds removal. There you can see a picture of the newest test which was done during the COVID, and it shows that we have a 5-log reduction of all viruses, bacteria, and mold that were tested. So with this new technology, we get a comprehensive microbial elimination. In hospitals, reduction of hospital-associated infections and surgical site infections. And when we use this unit 24/7, we also prevent surface contamination. This technology works without fiber filters, so it's also without pressure loss. And it's effective against particles, microbes, and gases. If we look at some of the hospital studies we have made, this is a study made in Western European hospital, actually in Italy, where we had a HEPA-equipped endoscopy room, and we received an 80% reduction in particle concentration within 24 hours. And they stated that this is a significant improvement and an optimal solution for high-risk areas. They also achieved a better ISO class, so ISO 6 with our unit. And they were measuring the particles, but what they stated, what's important is the reduction of other bioaerosol contamination by destroying the microbial loads carried by the particles. So the researchers came up with the recommendation after this study that when you combine Genano air treatment system with periodic biodecontamination, that gives you optimal results in a hospital. Another study, this is a university hospital in a developing country, and they had problems with surgical site infections. So they were studying operation theaters. They had two identical pediatric operation rooms where they assembled a Genano unit in one. The control operation theater, the surgical site infections was 31%, and with Genano 14.6%. So they received a 54% decrease in surgical site infections. And this is a clinical study which is published in a scientific magazine. And they also stated that beyond decreasing human suffering, this solution also presents hospital with significant cost savings because of the lowered infection amount. There has been a validation in NHS Scotland in UK. They tested our smaller unit in a ward, and they achieved the reduced amount of total viable counts levels, so microbes, by 62% with our small unit. And the mold levels were reduced by 82%. So they were stating that running the device in clinical areas reduced airborne microbial levels, and they expect there to be a reduction in the risk of airborne disease transmission. These are just few typical areas in hospitals where we use our technology. So airborne infection isolation rooms, operating rooms, and intensive care units. When you talk about the medical applications, the most common is just the unit which is effectively circulating the air and cleaning it. So it is not enough to bring fresh air into the room. you have to clean the particles and microbes, gases that are created inside the room. So this is a plug-and-play unit which can be rolled in and put to any room. Then we have references where we combine this with, for instance, with electric duct filters that are cleaning the air coming from the central systems. Then we have created positive pressure or negative pressure with this unit. Just a couple of cases fast from Italy during the COVID time. In Tuscany, they wanted to isolate the high-intensity departments which were dedicated to COVID-19 cases from the rest of the hospital. And they built negative pressure rooms with Genano equipment for about 20% of the cost than if they would have renovated the area. And they had a total decontamination of pathogens and the absence of filters for safety of staff and patients. And they are saying that the sampling was performed with the device running for 2 hours and no traces of the virus were detected in the air. In Belgium, in the largest hospitals, UZ11, they have been using Genano for a long time to protect patients in critical condition, to prevent spreading of diseases, and in IVF laboratories. And they say they do see a difference when Genano is in the room or not. In hematology, in Poland, we have delivered a lot of units to protect immunosuppressed patients after bone marrow transplantation. And what they are saying is we have seen the effect of Genano in practice, and without Genano, there would be very high risk of infections for the patients. There is just a list of some references. You can't probably see them very well, but our success in a country depends, of course, with how long we have had a partner and how successful they have been to introduce new technology. We have a lot of references in Europe, in Italy, and also Greece, Romania, Belgium. Romania is a typical market where they have very old hospitals and they are renovating them up to standards right now. And then we have worldwide references all around. To wrap it up, Genano advantages for hospitals is that we remove all size of particles, even nanosize. The process eliminates all viruses, bacteria, all microbes. We also remove gases and odors because we have no pressure loss, and we can use a very thick active carbon in the unit. And without fiber filters and pressure loss, we have a constant clean air delivery. So there is no variation. There are no filters to get saturated. And if we talk about the theme of today, sustainability, our units, because they are high voltage units, they have very low energy consumption. So it's basically only the fan in the unit. We have no pressure loss, so there is no increased demand for energy. And we have no disposable fiber filters, and very unique. We have a self-cleaning function, so the unit keeps itself clean automatically. This was all what I have. There was no questions allowed, I heard, so I thank you at this point.